everyone. My name is Durba Singh and I welcome you all on behalf of Academy of Earth Sciences. So recently, as you know, the GATE 2025 exam it was held, and I have come up with a video solution of the geology section questions of the GATE paper. Okay, so in this video, it consists of two parts, part 1 and part 2. Part 1 consists of the question number 11 to 30 solutions, and part 2 consists of the remaining question solution. I have discussed each and every question in a detailed manner so that it is clear to every one of you. I hope this video will be helpful to all of you. Okay, so let's start. Okay, so the first part of the GATE 2025 paper solution, it contains question number 11 to 30, as I have told you before. So let's start. I have not changed the question number. It is as per the GATE paper, so that it is convenient to all of you. Okay, now in the question number 11, what it is given that the most volcanically active body in our solar system. Options given are Mars, Io, Moon and Venus. Now see, in this question, what it is given about the solar system. We need to know about the planets and the satellites of the respective planets. Okay, so the planets that are given here are Mars and Venus, and the satellites are Io and Moon. Now, in the case of the Mars and also the Moon, it is such that the volcanic means activity of Mars is such that volcanoes are present in Mars. Like the biggest volcano which is present means the biggest volcano in the solar system is present in Mars, which is called as the Olympus Moons. Remember this thing. This is also very important from your other exam point of view. Olympus Moons. Okay, it is present on Mars and it is the biggest volcano. And in the case of the Mars, the super eruption or the biggest volcanic eruption that is known, it has occurred over 500 million year period. Means Mars, even though there are different types of volcanoes, even though it is present, but according to the volcanic activity, Mars is not considered to be so much active. Okay, next what we have Moon. Much of the Moon's ancient surface, it is covered by hardened lava. These are lavas which are formed by the basaltic flows on the surface. Now, most volcanisms on the Moon, it appears to have occurred within the time range of 3 to 4 billion years ago. Means you can understand that it is a long time range in which this volcanic activity has actually occurred. And nearest means the youngest volcanic activity, it is estimated to be of the age of about 1 billion years ago it has occurred. So in this case, Moon's volcanic activity is also not that means it is not as much volcanic active as we are generally considering. Okay, it is not most volcanically active. Next option is Venus. Now regarding the planet Venus, it is such that the volcanic activity on Venus, it is located in two regions. There are mainly two regions which are detected on Venus, which shows the volcanic activity at present. But in the earlier, the eruption that was occurred, it occurred in 1990s, and at present there are only two sites in which Venus shows a volcanically active region. It is present in the Estla region, Estla Regio region of Venus. Okay, now in the case of Venus, all these particular things regarding the volcanic eruption, like the evidence of atmospheric sulfur dioxide variation, surface thermal emission data, it confirms volcanic activity on the planet. But Venus is not the maximum volcanically active planetary body. Next what we have is Io. Now regarding Io, it is particularly a moon or a satellite of the planet Jupiter. Other two satellites are Europa and Ganymede. Okay, Io, it is also called as a volcanic moon. It is also called as volcanic moon. Means what? In the case of Io, there are hundreds of volcanoes that are located and they are active in nature in Io. and Io is the most volcanically active body of the solar system. Okay, means what? This particular mean satellite of Jupiter, which is also called as a volcanic moon. Why? Because it is the most volcanically active body of the solar system. That is why Io will be the answer to this question. Now, why is Io so much heated? Io, it is heated due to the strong gravitational pull of Jupiter on one side and the larger moons like Europa, Ganymede and Callisto on the other, which result in such volcanically active regions of the Io. This gravitational tugging stretches and bends Io, causing it to heat up, much as a ball of clay warms up as particularly you squeeze it repeatedly. Right? If you repeatedly squeeze a ball of clay, that clay will start to gain a internal heat, due to which it will start to be in different shapes. Similarly, the surface of Io, due to this gravitational pull of Jupiter on one side and the other satellites like Europa, Ganymede, Callisto on the other, results in such volcanic activity on Io, and therefore the surface of Io is mainly covered by large sulfur lava flows and irregular shaped mountain, and this makes Io the volcanically active body of the solar system, the most volcanically active body. So in this case, the option B will be correct. Okay, here for the question number 11, option B will be correct, which is the volcanically active body of the solar system is Io. Okay. Next question what we have is, given that question number 12, a type of fold which is relatively sharp and angular at its synform and antiform hinges is known as, options given are fan fold, drag fold, chevron fold and dome. Regarding the options, we will see first what is fan fold. Fan fold is, we generally know that it is when the limbs of a fold are overturned to such an extent that it looks like a fan. It is called as a fan fold. In this case, figure 1 shows the fan fold. See, here in the case of the fan fold, the limbs are overturned in such a manner that in an anticlinal fan fold, they are dipping towards the axial plane, and in a synclinal, they are dipping away from the axial plane. Okay, and in this case, what happens? Here the limbs are overturned. In a general fold, what we know, that this is the general fold. In a natural folded layer, this type the folds occur, but in a case of a fan fold, the layers are bended in such a manner that they get overturned, and at the hinge region they fan out in such a manner that it represents a fan like nature. Okay, they are called as a fan fold, and their main characteristic feature is that they particularly are overturned limbs are present. Okay, drag fold is one. Drag fold generally occurs within the particularly incompetent layer. Whenever there is a sandwich of competent and incompetent beds, the particular drag fold that forms when a competent or strong bed it slides past an incompetent or weak bed, they are also called as a minor fold. Means what? This is the figure of the drag fold. Within the incompetent bed, as they are weak in nature, and the competent bed as they are strong in nature, you can understand that the weak beds are easily deformable. So when they are actually sliding against the strong or the competent bed, they are resulting into a friction. There will be a friction due to the drag effect, and this results into the wrinkling of the layer, and these types of minor folds occur. They are called as a drag fold. And in this case, fan fold also, you can see the hinges, that is at the pointed part of the folded area. Here they are showing a broader curve. They are not angular in nature. Similarly, in the drag fold, what happens? The hinge, that is the trough, crest or the trough region, they are not actually regular. They are showing an irregular pattern. Okay, somewhere they are less folded, somewhere more folded. So angular nature is not present. Next, what we have is the chevron fold. Chevron fold is a fold in which they are mainly represented by sharp angular crest and trough. Okay, means what? These are the chevron fold where the crest and the trough regions are sharp in nature or angular in nature. Next, what we have is the dome. A dome is an anticlinal uplift that has no distinct trend. Means what? It is particularly showing that when the layers are folded in a manner that they represents a elevation, a positive elevation above the surface. Means what? When you will see above the surface, they will look like this, and when you are seeing the profile section, they are looking like this one, in which particularly the limbs are dipping away. Here also you can see they are dipping away. So the main area is uplifted here, then we are getting the limbs on this part. Okay, so this is the oldest formation, then we are getting the other beds. So this is a dome in which they are particularly have no distinct trend, and so you can understand there is no crest or trough region where we can identify the particular means angularity. So in this case, the chevron fold is the fold which shows an angular and sharp region at the synformal and antiformal hinge area. Means what? Synformal or antiformal hinge area means what? They are the crest and the trough regions. Okay, so in this case option C will be correct. Okay, next what we have is the question number 13. Question number 13, what it is given? In the case of question number 13, which one of the following geophysical method can provide information on deep earth structure of the order of 1000 km below the surface with high resolution? Means what? We are being asked about that geophysical method that can provide us information about the earth structure which are present at about a depth of 1000 km below the surface, and that is a high resolution method by which we can particularly determine the earth structure. The options that are given are seismic method, magnetic method, electrical method and gravity method. Now let's see about these methods. Now see, here I have given a tabular means explanation, which will be it will be very clear to you once if you go through this table. What it is given here, the gravity method, it is particularly used to measure the physical variation, that is density contrast in subsurface layer. The lateral density contrast is being measured within the gravity method, the lateral contrast, and here particularly those massive barite ore bodies and chromite ore bodies are particularly detected. So you can understand that these means gravity method is actually the method which is measuring the lateral density variation. The depth range is not so much in the case of the gravity. Okay. Magnetic method, it measures the magnetic susceptibility, and it generally used to detect kimberlite bodies, iron containing ore minerals. These are also present near the mean surface, and here also the particular means depth range is not so much. In the case of electrical method, there are different types, that is the resistivity method used to measure the conductivity or the resistivity of the subsurface ore body if present, or different groundwater if they are present, they are used for groundwater exploration, mineralized conductive vein deposits, study of geological structures. Okay. Next what we have, self potential or SP method. SP method is used to calculate the induced potential difference, and it is used to detect the massive sulfide deposits. Okay. Next we have the induced polarization method. They are used to measure the electric current that is flowing through a medium, and it is particularly used for detecting the disseminated sulfide deposits. Okay, now in all these three methods you can see that in the case of the resistivity method, it is used to study the geological structures, but in this case the deep earth structures means what? That is the different layers of the earth, the discontinuities that are present. These particular properties are not being measured by the resistivity method, rather different geological structures which are present within the subsurface region near to the surface, they are mainly measured. Here also the depth range is not so much. Okay. In the case of seismic method, now whenever we hear about a seismic method, what generally come into our mind? That is, this method is mainly used to determine the different layers of the earth, the S wave, the P wave. They are sent within the subsurface regions, and the crust, mantle, the core characteristic features, they are determined. Okay, the depth of the particular layers, they are determined, the thickness, the discontinuities that are present. So these are what they are, particularly the earth structure within the deeper regions that are being detected by the seismic method, right? Now in this case, the method is mainly used to measure the physical variations like the seismic wave energy travel time. From this travel time, we can determine the particular time for which the wave have traveled and the depth at which that earth structure is present. And in this case, the detection, it provides information with the highest resolution on Earth's internal structure or deep earth structure of the order of 1000 km. This is one. Another use is for hydrocarbon exploration. Okay, so in the case of the seismic method, this is the method which is particularly giving a high resolution depth measurement of about 1000 kilometers below the surface of the earth, by which the earth structure can be determined. Means different clearings within the earth can be determined. Okay, so it is given here, among geophysical methods, seismic method is considered the most effective geophysical method for providing high resolution information about deep earth structures reaching depth of around 1000 kilometers by analyzing the reflection of seismic wave of different rock layers with varying densities and compositions, right? Because we know that within the particular core region, the outer core and the inner core, the outer core is liquid, inner core is solid. Outer core is liquid, so that S wave or the secondary wave cannot penetrate through the liquid, and the P wave can penetrate. So from there we can determine that the outer core is liquid in nature, right? In similar way, the upper mantle, lower mantle behavior is also identified, the low velocity zones are identified. So seismic method is the method by which the deeper earth structures with high resolutions of order of 1000 km can be detected. So in this case, the option A will be correct. Okay, answer for question number 13 is option A, seismic method. Okay, next what we have, question number 14. In the case of question number 14, what it is given here, very simple question. The continuous series of Bowen's reaction series is represented by, options are orthoclase albite feldspar system, anorthite albite system, phosphorite phyllite system, and diapside anorthite system. So here the options that are given. Before going to that, we should know about the Bowen's reaction series. What does the Bowen's reaction series tells us? There are two sides of the Bowen's reaction series. On the left side we have the discontinuous series, on the right side we have the continuous series. This image is picture shows the Bowen's reaction series. In the case of the continuous series, what it is showing, the continuous series, this is the continuous limb of the Bowen's reaction series, or the side of the Bowen's reaction series. It is mainly depicted by the plagioclase feldspar, starting with the calcium rich Ca plagioclase and ending at the sodium rich Na plagioclase. Means what? That is the albite, this is albite, this is anorthite. Okay, this is albite, this is anorthite feldspar is being shown here. So the albite anorthite system is showing the continuous side of the Bowen's reaction series. So the albite anorthite system is the option which will be correct. This is correct. Others that are given here are orthoclase albite feldspar system. Now see, in this case, the particularly potassium feldspar, this is showing us that is the orthoclase. So the orthoclase albite system is not actually showing the part of the continuous reaction series. It is out of the continuous reaction series. So it is not the option correct. Okay. The phosphorite phyllite system, this is particularly the olivine minerals. In the case of the olivine minerals, it is mainly shown at the discontinuous side of the Bowen's reaction series. This is the olivine. So the phosphorite phyolite system is not the continuous series. Diapside and orthite system, that is pyroxene plagioclase system, is being shown here. So pyroxene and plagioclase are on either sides of the Bowen reaction series and representing the discontinuous side and the continuous side. So they are also not showing a continuous series. Okay, only that the continuous series is shown by albite and orthite system. Means what? If you if you start with albite and end at anorthite on this part, we know that the minerals that are present at the middle, okay, means what? Albite, oligoclase, andesine, labradorite, bituminite, anorthite. This is a continuous series which is represented by this system, and this represents the continuous series of Bowen's reaction series. So here the answer for the question number 14 will be option B. Okay. Next what we have is, which of the following time boundary corresponds to major mass extinction events? Means multiple select question we are talking about. More than one option will be correct, right? So here the options that are given here, we are asked about the major mass extinction event. Major: Cretaceous, Paleogene, Paleogene, Neogene, Permo-Triassic and Precambrian, Cambrian. So in this case we will see with this table. Okay, here the mass extinction, that is the there are mainly, we know, 5 mass extinction event that had occurred. What are they? Permo-Triassic or the end Permian mass extinction, the Ordovician Silurian extinction, Cretaceous Paleogene or the KT Cretaceous Tertiary event also called, end Triassic extinction, and the Devonian extinction. Now in the case of the Permo-Triassic extinction, it has actually been the most drastic die out. Means this sequence that I have given here, this shows the the maximum extinction to the minimum level, that is the ascending order of the extinction events that had occurred. So in this case the Permo-Triassic extinction is the most drastic mass extinction that has occurred, and it had mainly wiped out about half of the taxonomic families, including 90% of all species were excluded. Means they were wiped out, they became extinct. Okay, and this included 95% of the marine species and 70% of the land species. So this Permo-Triassic is the most drastic event of mass extinction that occurred. So in the option, do we have that? Yes, Permo-Triassic is an option that we have. Next extinction that occurred is Ordovician Silurian extinction. It eliminated about 25% of the marine families and 85% of the marine species. Okay, so Ordovician Silurian extinction, do we have? No, we don't have that option. Next we have Cretaceous Paleogene or the Cretaceous Tertiary event. It particularly resulted in elimination of 80% of all animal species, and here the dinosaurs were also became extinct. Okay, so Cretaceous Tertiary, do we have? Yes, Cretaceous Paleogene, or it is called as the KPG extinction that occurred. Okay, next what we have is the end Triassic extinction. This eliminated about 20% of the marine families and 76% of all extant species to die out, and this is the 4th mass extinction event that occurred. End Triassic, do we have? No, we don't have that option. Last is the Devonian extinction. It resulted in eliminating 15 to 20% of the marine families and 70 to 80% of all animal species on the earth. Now Devonian, do we have Devonian extinction? No, we don't have that in the option. So these two options, that is A and C, are correct. Okay, so for option question number 15, option A and C will be correct. Other two, that is the Paleogene, Neogene and Precambrian, Cambrian, these are not the mass extinction that occurred during this time, so they are not the correct options. Okay, question number 16, what it is said here, that A watershed has an area of 74 square kilometer. The stream network within this watershed consists of 3 different stream orders. The stream length in each order as follows. Okay, now here it is given that the first order stream lengths are being given. Now second order stream that are present, lengths are given, and the third order stream, only one stream is present, its length is given. The drainage density of the watershed is, okay, is kilometer per kilometer square. Round off to 2 decimal place, it is being asked for the question. Now what is drainage density? Drainage density is actually of a watershed. It refers to the total length of all stream within a watershed divided by the total area of that watershed, essentially including how densely the stream are distributed across the land, and is usually expressed in kilometer per square kilometer. In other words, drainage density is the sum of the length of the stream per unit drainage area within the basin. Okay, means that is that the drainage is dense or not. This the value of drainage density will actually tell us. Now in the case of drainage density, the basic formula that is used here is adding all the length divided by the area of the drainage basin or the watershed that has been given. So I am doing it here. So the drainage density dd is summation of stream length of all orders divided by area of watershed. Okay, this is the formula that we are going to use. So drainage density that we have here is the first order drainage that we have. The length of the streams are 3, 2.5, 4, 3, 2 and 5. We are going to add all of them: 3, 2.5, 4, 3, 2 and 5. The second order that we have is 10, 15 and 7, and the third order is 30. This is giving us a kilometer value. And next area that we have is 74 square kilometer. 74 kilometer square. We will not cancel out the units here. Okay, so the drainage density, adding all this value, will give us 19.5 plus 32 plus 30 divided by 74 kilometer square. So finally we are getting 81.5 divided by 74 kilometer per kilometer square. This is giving us a value of 1.10. Okay, 1.10 kilometer per kilometer square. Okay, this is the answer that you are getting. Okay, near about, plus minus means you can say that 0.05 could occur. Okay, now okay, here the value variation that can occur is, you can know that depending upon the calculators, the values are different. So here the value can be from 0.08 to 0.13, means 1.08 to 1.13 value variation can occur. This is the answer that I have got, and this is the answer of question number 16. Okay, question number 17, what it is said. Now, a sample contains 7 weight % CaO and 5 weight % MgO. The molar ratio of CaO to MgO in the sample. Now, it is given here. What it is given here? Okay, round off to 2 decimal place we are asked. Now, we are given with 7 weight % CaO and another we have 5 weight % MgO. Now, in this case, we are asked with the molar ratio, means number of moles of CO to that number of moles of MgO. Now, if we assume Now if we assuming 100 grams of the given sample, right? In this case we have 70 grams of CaO and 50 grams of MgO, just assuming so that we can get the weight percent within gram. Okay, now if we are particularly converting to number of moles, okay, converting to number of moles. Now here we know that the molecular weight of CaO, it is near about 56.08 gram per mole, and molecular weight of MgO is 40.31 gram per mole. Okay, so number of moles, if we want to know number of moles, it is obtained by the given sample weight by the molecular weight of the sample that is given here. So in the case of the number of moles of CaO, it is how much? 70 grams by 56.08 gram per mole. This is gram is cancelled, so mole we are getting 1.25 moles. Similarly, number of moles of MgO is 50 gram by 40.31 gram per mole. This is giving us how much? That is 1.24 moles. So if we take this as N1 and this as N2, so the molar ratio N1 is to N2, that is the number of moles of CaO to number of moles of MgO. It is how much? 1.25 divided by 1.24, that is giving us a value of 1. Okay, so this is the answer for this question. This has give us a value of 1. Okay, next question number 18. Select the option that lists oxide mineral only. Oxide mineral only we are asked about. Okay, options are given here, and in the means table also I have given you the chemical formulas of each of the minerals that are given in the option. Spinel, we know the chemical formula is MgAl2O4, corundum Al2O3, rutile TiO2, olivine MgFe whole to SiO4, pyroxene XY SiAl whole to O4, whole to O6. Magnetite is Fe3O4, apatite is Ca5PO4 whole 3 FClOH. Galena is PBS, monzonite given here, it is also a silicate mineral, or a particular means it is a silicate mineral, not an oxide. Fluorite is CaF2, halite NaCl, calcite CaCO3. So in this list of minerals that have been given, only we can see that option A, that is spinel, corundum and rutile, they are only giving us a oxide mineral. Others that we can see that olivine is a silicate mineral, pyroxene is a silicate mineral, magnetite is an oxide mineral, apatite is a particularly phosphate mineral, galena is sulfide, late sulfide, monzonite is similarly silicate and phosphate combination, and fluorite is fluorite mineral, halite is NaCl chloride mineral, sodium chloride, calcite is carbonate mineral. In this case, only option A is giving us the list of oxide minerals. So for question number 18, option A will be correct. Okay, very simple. For this we need to know only the mineral formula. Okay, तो भाई जिसका मिनरोलॉजी मतलब अच्छे से किया हुआ होगा वो इजीली इन सब मिनरल्स के मतलब ऑप्शंस टिक कर पाएंगे. Okay, for this thing you should know also the means hardness scale or the Morse hardness scale that we know. Okay, that will also help you in this question. Next what we have, Consider two intersecting northeasterly striking and southeasterly dipping dike Y1 and Y2. Question number 19 we are starting. Okay, which are exposed on an east-west trending vertical wall of a granite X quarry as shown below. Now, in this case, we are given with two dikes Y1 and Y2. If we take this as north, south, east and west, the strike that is given here is northeasterly striking, right? Northeasterly striking and southeasterly dipping. Southeasterly dipping. This is the dip. Okay, the amount of dip, which is 90 degree. This is the true dip that we are talking about, and this particular direction is the true dip direction. Okay, other than this, any dip that is being calculated between the strike and the true dip line is the apparent dip. Okay, so in this case we are talking about that these two dikes whose strike and dip are being given are exposed on an east-west trending vertical wall of granite. Okay, this is the granite quarry. It is shown the angle that the dike makes with the horizontal on the quarry wall means what? Here particularly the dip, true dip is in this direction. So in this direction, this is the perpendicular to the strike line. So the angle that the dike makes with the horizontal on the quarry wall means what? This particular wall, that is the east-west wall, trending wall, it is a vertical wall that we are talking about. This is a vertical wall, and on particularly the horizontal wall, this particular means region that we are talking about, they are asking what is the particular angle that the means dikes are making. What it is called? It is the true dip, apparent dip, rake or attitude of the foliation. Now what is the true dip? It is particularly the angle that a particularly inclined strata or bed is making with the horizontal plane that is measured on a vertical direction. Okay, that is measured perpendicular to the strike. Okay, this is the true dip. This is measured perpendicular to the strike at 90 degree. Apparent dip is what? It is the angle between a horizontal plane and a geological formation plane measured in any direction other than the true dip direction. And true dip is always greater than the apparent dip. Other than when the section is perpendicular to the strike line, apparent dip and true dip are equal. Okay, other than that, if the section is not perpendicular, any angle which is not equal to the true dip and that is measured between the horizontal plane and that of the inclined bed will be the apparent dip. Okay, in this case what we can see, that the angle that the dike makes with the horizontal will be actually the apparent dip, because this is the angle that the dikes are making with the horizontal other than the true dip we are talking about. Okay, other options that are what? Rake is the angle measured within an inclined plane between a horizontal line and the line in question. Means what? It is for the linear structure we are talking about, and here it is the particular planes we are talking about. So rake is not the option. Attitude of foliation. Now see, foliation planes, they are the planar features. The attitudes for these planar features that are given are in the format of strike, dip, dip direction. That is in the azimuthal way if we are talking about. That is wholly number based, only that the dip direction is indicating the direction. So it is southeast or northeast, like this, quadrant based. Other than that, if it is a particular quadrant based method, then along with the quadrant value, numerical values are also used, where strike, dip and dip direction is being used here. Okay, understood? So in this case you can understand that the angle that the dikes are making with the horizontal, it is particularly the apparent dip, angle that the dikes are making with the horizontal. Means what? if this angle was 90 degree to that of the strike line, then it would be true dip. But it is an angle which is not 90 degree to the strike line, but it is an angle which is measured between the right, that is the strike, and that of the horizontal, means it is an apparent dip. Okay, so for this question option B will be correct. Next, question number 20. The ratio of P wave and to S wave velocity Vp by Vs within the Earth's depend on. The ratio will depend on the means options that are given are bulk modulus, shear modulus, density, coefficient of internal friction. Okay, now we know that generally we define the particular bulk modulus as K, the shear modulus, or it is also called as the rigidity modulus. Rigidity modulus, it is defined as mu. Density, it is defined as generally rho, and coefficient of internal friction phi. So in this case, the Vp by Vs ratio, for that particularly the Vp value and Vs value we should know. Vp value is given here, that is root over K plus 4 by 3 mu by rho, and Vs is root over mu by rho. So here K is the bulk modulus which measures the material's resistance to change in volume. Mu is the shear modulus or rigidity modulus which gives the material's resistance to change its shape. Okay, and rho is the density of the material. Now if we put Vp by Vs, this value we need to know, right? So we are getting it K plus 4 by 3 mu by rho, 4 by 3 mu by rho, and this is mu by rho. So Vp by Vs, this ratio, if we take K plus 4 by 3 mu rho, this one into rho by, okay, before doing this I will simplify this thing, Vp by Vs into numerator, that is 3 rho K plus 4 mu by 3 rho divided by rho by mu. This is the thing. So if we take this, that is I am doing it here, okay, Vp by Vs root over 3 rho K plus 4 mu into rho by 3 rho into mu. So rho cancelled out. Okay, now this value I'm writing it here, Vp by Vs is equals to root over, it will simplify into K plus 4 by 3 mu divided by rho. Okay, this will be the ultimate result that we will get. Now in this case you can understand from this question that overall Vp by Vs ratio, it is depending upon mu and rho, okay, and also K. Now density of the material, it is fixed. Now so it is particularly depending upon the value of K and mu. So in this question what it is given here, that the ratio of the P wave and S wave velocity within the earth, it depends on which factor? Bulk modulus, shear modulus, and particularly density or coefficient of internal friction. Now see, in this case density will not be an answer as it will be constant, right? But within that particular medium, the bulk modulus, that is the particular value of bulk modulus and the rigidity or shear modulus of that medium will differ depending upon the overall means region we are traveling. But the density value, it will be constant. So Vp by Vs value, it will mainly depend upon the value of bulk modulus and shear modulus. Okay, so here the option A and B will be correct. Okay. Next what we have is the question number 21. Here it is given that 3 pixels PQR is in an image are characterized by the ND value of plus 0.84, plus 0.01 and minus 0.89 respectively. Which of the following option is or are correct? Options are given here are P is from vegetation area and Q is from barren area, barren land. Q is from water body, R is from barren land. Q is from barren land, R is from water body. P is from vegetation area and Q is from water body. Now regarding the NDVI value, what is this value is that it is particularly representing the normalized difference vegetation index. It is given by the formula, it is given here, and from here we can particularly determine that a particular region is consisting of how much vegetation, whether it is consisting of a sparse vegetation, whether it is densely vegetated, whether it is a barren land, whether a water body is present here. Like this we can determine the value depending upon means the nature of that land, depending upon the value of NDVI. Now in the case of NDVI, it is given here that the value ranges from -1 to +1. Minus values indicates that it is an water body and positive value +1 indicates dense green forest. So in this case the plus value, it is indicating what? That is vegetation. Okay, next what we have towards, that is plus 0.01. Plus 0.01 means what? That is we are talking about the value of Q. Means what? They are consisting of lands which are not showing any vegetation. Means what? They are representing barren lands. Okay, and means lesser plus value, and minus this value, it is representing what? That is the presence of an water body. So this is actually P, Q, R. So P is representing vegetation, Q barren land, and R is representing water body. So from here the question number 21, the option A is given here correct. P is vegetation area, Q is barren land, and B is given here, that is Q water body. No, it is wrong. C, it is given here Q is a barren land and R is water body. Yes, it is correct. D, it is given here P is vegetation area, correct. Q is water body, it is wrong. So for this question number 21, option A and C will be correct. Okay, I hope it is clear. Next it is given here in question number 22, which of the following can indicate the presence of significant subsurface iron mineralization? Subsurface iron mineralization, okay, means the presence of Fe2 plus Fe3 plus ions. Now in this case the options given here are free air gravity anomaly, Boger gravity anomaly, magnetic anomaly, and electrical resistivity measurements. Here in the table we are giving you the particular definition, means definitions, along with that the use of particular method. Tabular form it is given here so that it is clear to you. Free air gravity anomaly, this measures variation in gravity without correcting for elevation or topography and is not typically used for detecting subsurface mineralization. So free air gravity anomaly is not an option, correct option. Borger gravity anomaly is what? This particular anomaly, it measures what? That is the subsurface density variation. The density variations that are created due to different mineralization means in the subsurface region. Borger gravity anomaly is mainly used to measure them. The iron ore deposits are mainly the deposits that are having a high density. Due to this high density, they are particularly having a contrasting density variation with respect to the surrounding rock, and they leads to a positive gravity anomaly value, and this value is mainly measured by the use of the Borger gravity anomaly. And this anomaly method gives us an effective identifying measurement technique of high density bodies like the iron mineralization that are present at the subsurface region. And so Borger gravity anomaly is mainly a reliable indicator of subsurface mineralization, iron mineralization particularly. Okay. Magnetic anomaly, they are caused by variation in the Earth's magnetic field due to the presence of magnetic minerals like magnetite and hematite, which are common in iron ore deposits. High magnetic anomaly values are strongly correlated with iron ore mineralization. Okay, so in this case, the magnetic anomaly values are also here mainly considered. Okay, means what? The magnetic method is also here mainly used because we know that the iron minerals, they are magnetic in nature, and due to their presence the magnetic anomalies are being formed with respect to the surrounding rocks, and so this method is also used to measure the subsurface iron mineralization. Electrical resistivity method. When resistivity method means in this case, it can provide useful data about subsurface materials that are present. They are less specific and reliable for directly identifying iron ore compared to gravity and magnetic method. Means what? In the case of the Borger gravity method and the magnetic method, where we can particularly identify the means iron ore mineralization, where they are present, how much present, and what is their shape. The electrical resistivity method, even though they give us some idea about the subsurface materials that are present, but they do not give us a vivid idea of the mineralization that is present. So it is not used for identifying these types of ore bodies. Okay. So here particularly the mineralization that are used are means anomaly methods that are used are Borger gravity anomaly and magnetic anomaly. Okay, so the option will be B and C for question number 22, which will be correct. Okay, I hope it is clear. Next we have question number 23. Very simple, easy question. Okay, which is given here. Which of the following statement is or are correct? Means multiple select question. They are MSQ type question. Is or are correct regarding the magnetic field lines of the earth at the magnetic pole and the magnetic equator. Now whenever we are talking about the magnetic field lines at the magnetic pole and magnetic equator, what we know that the options that are given, we will first see that they are horizontal at the equator, vertical at the pole, horizontal at the pole, vertical at the equator. Very simple question. Generally when we see a bar magnet behavior, in this case the bar magnet is shown here. This is the bar magnet, okay, which is present at the center of the earth, aligned to that of the north-south axis of the earth. Now in this case we can see these are the magnetic field lines which are emanating out from the south, and they are particularly shown at the north-south orientation. Now in this case what happens? These field lines, they are actually showing that they are perpendicular at the magnetic poles and they are parallel to the earth's surface. Okay, they are parallel to the earth's surface, whereas they are perpendicular at the magnetic pole region. Okay, this is a characteristic feature of the magnetic field lines. Okay, now in this case the options that are given here are horizontal at the equator. It is correct. The magnetic field lines are horizontal to the earth's surface at the equatorial region. They are vertical to the poles, that is the magnetic poles, right? So option A and B are correct, whereas C and D are not correct. At the Earth's magnetic pole, the magnetic field lines are perpendicular to the surface of the Earth, pointing directly into the Earth at the north magnetic pole and directly out at the south magnetic pole. While at the magnetic equator, the field lines are parallel to the Earth's surface, running horizontally along the equator. Understood? This is the particular case. So for the question number 23, option A and B are correct. Okay. Next we have, if the lowest digital number dn value in an image is of 10-bit geometric resolution is 0, then the maximum dn value of that image is. It is asked about a remote sensing question, very simple question. For this, what we need to know is particularly a small formula, very small formula. Now first we will see what are given here. That is the lowest dn value, it is given here, which is 0. Then we are given with the particularly bit value. What is the bit value of image? Generally represented as x is 10 bit, right? And in this case, the formula that we are going to use is that the radiometric resolution of an image, it is given by the formula 2 to the power x, and x, you know that it is giving the bit value of an image. So 2 to the power x, here what will be 2 to the power 10, right? 2 to the power 10, the value will be 1024. So here we are asked about the maximum digital number value, that is the maximum dn value of the image will be. So the lowest dn value is 0. So the maximum dn value of the image, if you are thinking that it will be 1024, you are absolutely wrong. It will be 1023. हमें पता है ना कि 10 नंबर अगर हम बोल रहे हैं तो मतलब क्या है, 0 to 10, 1 to 9, 1 like this we are talking about. Now जैसे ही हम we are counting on our fingers, means what, we are actually decreasing the upper case or the lower case, तभी हमें सब वहाँ पर मिल रहा है, the values we are getting. So the minimum is 0, maximum will be 1023, and that will give us a total radiometric resolution of 1024. Understood? So the answer will be 1023 for this question. It is given here, question number 25, that is, if 1 liter of water at pH 7 is mixed with 1 liter of water at pH 6, the resulting pH of the mixture is, round off to 2 decimal place. बहुत ही सिंपल सा एक क्वेश्चन है. यहाँ पर क्या पूछा गया है, pH के बारे में पूछा गया है, और यहाँ पर अगर आप सोचेंगे कि सिंपल ऐड कर देंगे तो that will be absolutely wrong. pH 6 plus pH 7 will give us a value of pH 13. That will be absolutely wrong answer. यहाँ पर क्या होगा, आपको H plus ion concentration का value वहाँ पर importantly यहाँ पर काम करना पड़ेगा. That is, पहला क्या दिया गया है, that is pH दिया गया है 7. pH 7 के लिए हमें क्या मिलेगा, the H plus ion concentration will be 10 to the power minus 7. As we know that pH क्या होता है, pH equals to minus log of H plus ion concentration, right? So यही यहाँ पर पुट करके हमें ये मिल रहा है. सेकेंड केस में कितना दिया गया है, pH 6, तो H plus ion concentration will be 10 to the power minus 6, right? Now in this case 10 to the power minus 6. So for here, if we are getting the H plus ion concentration, क्या होगा, अगर हमें यहाँ पर एक सिंपल सा एक मतलब फॉर्मूला जानना है, that is molarity. Molarity is actually giving us, that is the number of moles by the volume, that is N by V. ये आपको जानना पड़ेगा, ठीक है. यहाँ पर क्या दिया गया है, that is बहुत ही सिंपल है. दिस इज 10 to the power 7 mole and this is 10 to the power minus 6 molarity. Now 10 to the power, so अगर हमें नंबर ऑफ मोल्स निकालना है दैट विल बी मोलरिटी m इंटू v वॉल्यूम. सो अगर इसे फॉर दिस पर्टिकुलर कंडीशन वी आर टेकिंग n1, उसके लिए हमें क्या मिलेगा 10 to the power minus 7 into 1 volume, that is 1 unit of volume, 1 liter of water. Similarly n2 के लिए हमें क्या मिल रहा है 10 to the power minus 6 into 1 liter. This will be liter, right? This will be liter. उसका वॉल्यूम का जो होगा ये भी liter. So in this case if we are getting the net mole n1 plus n2, कितना हमें मिल रहा है दैट इज 1 into 10 to the power minus 7 प्लस 1 into 10 to the power minus 6. ठीक है, और इसको अगर हम सिंप्लीफाई कर लेंगे, इसको अगर 10 to the power minus 7 में लाएंगे तो क्या होगा दैट विल बी 10 into 10 to the power minus 7. We are multiplying and dividing with 10. So 10 to the power minus 7 will be common. We are getting 1 plus 10, that is 10 to the power minus 7 into 11. Now as it is, we are talking about that the overall net concentration. If we are talking about net H plus ion concentration, this will be how much 11 into 10 to the power minus 7 whole divided by 2, as we are talking about two particular solutions. Now this will give us a value of how much 5.5 into 10 to the power minus 7. ठीक है, अब इस H प्लस आयन के वैल्यू को, ये जो हमें मिला, इसको हम कहाँ पे पुट करेंगे दैट इज वी आर पुटिंग इट इन द pH. pH इक्वल्स टू माइनस लॉग ऑफ H प्लस आयन कंसेंट्रेशन, दैट इज 5.5 into 10 to the power minus 7. This will give us a pH of into है, मतलब क्या होगा प्लस हो जाएगा, माइनस लॉग 5.5 माइनस ऑफ, जब लॉग 10 to the power minus 7 करेंगे तो माइनस 7 आएगा, दैट विल बिकम हाउ मच दैट इज सॉरी इट विल बी प्लस, ये क्या होगा माइनस. सो pH का क्या होगा लॉग 5.5 माइनस में है, वो कितना आएगा दैट विल बी, ये जो पर्टिकुलर मतलब माइनस माइनस ये क्या होगा प्लस हो जाएगा. सो माइनस ऑफ माइनस 7 इट विल बी प्लस. सो प्लस 7 माइनस ये जो वैल्यू है 0.74, सो इसका कितना आया 6.26. This will be the answer. Understood? This will be the answer. ठीक है. Next what we are getting question is question number 26. Question number 26 क्या दिया गया है? A hill slope is shown below. If the area over the failure plane is 50 meters square and the weight of the hill slope material is 2000 tons, the factor of safety FOS for this hill slope in dry condition is how much? Cohesion along the failure plane it is given, dip of the failure plane it is given, internal friction it is given. Answer is asked within 2 decimal places. So given parameters cohesion, weight, area, dip of the failure plane, internal friction, ये हमें सब पता है, right? It will be 5. internal friction ये हमें पता है. नेक्स्ट यहाँ पर क्या दिया गया है दैट इज जो फॉर्मूलाज यहाँ पर यूज करने वाले हैं हम लोग, वो है ये. आई हैव रिटन इट इन वन प्लेस फॉर योर कंसिडरेशन. देखो क्या है, नॉर्मल स्ट्रेस सिग्मा एन, shear स्ट्रेस टाउ, shear स्ट्रेंथ, फैक्टर ऑफ सेफ्टी. फैक्टर ऑफ सेफ्टी मतलब क्या है, इट इज shear स्ट्रेंथ बाय shear स्ट्रेस. सो यहाँ पर जब हम वैल्यू पुट करेंगे दैट विल गिव अस अ नॉर्मल स्ट्रेस सिग्मा एन, ये क्या होगा दैट इज 19620, दैट इज W then into cos of 60 degree, this divided by area 50, right? This will give us a value of sigma n, that is 196.2 kilopascal. Now shear stress, ठीक है, टाउ का वैल्यू क्या होगा, that is 19,620 into sin थीटा मतलब 60 डिग्री डिवाइडेड बाई 50. तो टाउ का वैल्यू क्या होगा, टाउ का that will be 339.6 kPa, ठीक है. Then we are getting here क्या, that is the shear strength. shear strength कितना होगा, that is 196 जो कि है कोहेशन का वैल्यू प्लस सिग्मा n tan phi, that is sigma n 196.2 into tan phi, internal friction 30 degree, ये है, right? So this will give us a shear strength value of 305.4 kPa. Then therefore FOS, that is the particular factor of safety, it will be shear strength by shear stress. Shear strength is 305.4 kPa, shear stress 339.6 kPa. So 305.4 kPa, then 339.6 kPa cancelled out. Then FOS का वैल्यू क्या होगा, 0.91. Now as the value of FOS it is less than 1, ठीक है. Now as the value it is less than 1, this particular value it indicates that the slope is unstable under dry condition, ठीक है. ये overall solution है and the answer is 0.91 for this question. Question number कितना है, that is 26. Question number 26 के लिए the answer is 0.91. okay, FOS value. okay, 27 देख लीजिए. Which one of the following statement explains why why elements like lithium, beryllium and boron has low cosmic abundance? Options क्या है, these elements have low masses and hence they break apart easily. B, these elements have low binding energies which makes them unstable at high temperature at the core of the stars. C, the low abundance of these elements is a unique feature of big stars which with masses greater than 10 times than of our sun. And option D is these elements are highly reactive and hence unstable. Now see, regarding elements lithium, beryllium and boron, what do we know? That they are actually rare in nature and they are fragile light nuclei. These elements, they are rare and their nuclei are fragile in nature and hence they have low cosmic abundance because they are easily destroyed in stellar interior. Why? Because at the interior of the star we generally know that the heat will be high and there these types of fragile light nuclei could not exist. okay, and there is particularly the formation of helium or hydrogen, वहाँ पर helium form करता है जो एक high amount of energy process है and are primarily produced through a rare process called cosmic ray spallation, जो कि rarely occur करता है within the cosmos. where high energy cosmic rays they collide with heavier nuclei, breaking them apart to form these lighter elements. This means their creation is infrequent compared to other elements synthesized in star during nucleosynthesis. मतलब क्या है, nucleosynthesis के टाइम पे जो भी हमें दूसरे elements like the helium we are getting and which depending on which the age of a particular mean star could be determined, ये जो elements है that is lithium, beryllium, boron, ये rare होते हैं, fragile नेचर के होते हैं, इसीलिए ये जो होते हैं they are having a low cosmic abundance as these elements they cannot survive the high amount of heat within the star's interior and they are formed via rare process called cosmic ray spallation. ठीक है, तो यहाँ पर जो ऑप्शंस दिए गए हैं उसको हम देखते हैं. These elements have low masses and hence they break apart easily. देखो ये जो एलिमेंट्स है ये रेयर है, ये फ्रेजाइल है, तो ये क्या होता है, ये कॉस्मिक एरियाज में वो सस्टेन ही नहीं कर पाते, तो वो होगा ही नहीं, तो वो ब्रेक अपार्ट कैसे होगा. सो दिस ऑप्शन इवन दो इट इज पर्टिकुलरली कंफ्यूजिंग बट इट इज नॉट द करेक्ट ऑप्शन बिकॉज दे आर हैविंग very means rare presence within the particular stars and so their cosmic abundance is very low. So these elements they will actually not be present in such an amount कि वो break apart हो सके. Next क्या है, these elements have low binding energies which make them unstable at high temperature of the core of the star. सही बात है, क्योंकि why? Because these elements are fragile in nature, they do not have a higher binding capability जिसकी वजह से वो bind upon नहीं कर पाते and they break upon. ये एक important explanation है about these types of elements. This is the correct option. The low abundance of these elements is a unique feature of big star which with masses greater than 10 times of our sun. ये कोई करेक्ट एक्सप्लेनेशन ही नहीं हुआ, क्योंकि लो अबंडेंस ऑफ अगर ये होगा और इसका एक्सप्लेनेशन क्या है दैट दीज एलिमेंट्स आर पर्टिकुलरली ऑकरिंग विद इन द बिग स्टार विच इज़ द यूनिक फीचर ऑफ द बिग स्टार. बिग स्टार जितना होगा देयर एज विल बी मच लेस, वाई दे आर बर्निंग आउट एट अ फास्टर रेट एंड ये इसका एनर्जी भी हाई होगा, तो वहाँ पर ये दीज टाइप्स ऑफ एलिमेंट्स विल नॉट बी प्रेजेंट. Wrong. These elements are highly reactive and hence unstable. Now you can understand that they are, for option B we are talking about that they are having low binding energy, they are fragile in nature, so उनका जो reactivity होगा वो कैसे high होगा. They are least reactive, that is why they are not binding to each other. अगर वो reactive होते तो bind upon कर जाते and they would have been a high cosmic abundance. है नहीं, तो ये option भी correct नहीं है, right? So they are not having a high reactivity, rather a low binding energy results into a very low reactivity and hence they are unstable. ये option correct नहीं है. For this the option number B will be correct. Okay. Next question that we are going to see is question number 28. क्या दिया हुआ है इस question में, देख लीजिए. That it is asked that during a geochemical exploration survey in a hilly terrain, copper concentration of the stream sediments from a third order basin outlet was measured to be 3000 ppm, that is parts per million. Considering a catchment area of 10 square kilometer and a copper background value of 200 ppm, which of the following option is the productivity of this catchment for copper concentration? Means what? We are asked with the productivity value of the catchment for the copper concentration, right? अब जो भी यहाँ पर ऑप्शंस दिए गए हैं वो आपको दिख रहे हैं. प्रोडक्टिविटी अब हम देखते हैं क्या है. सी प्रोडक्टिविटी क्या होता है, इट इज एक्चुअली द रेट ऑफ प्रोडक्शन ऑफ सर्टेन एलिमेंट, यहाँ पर क्या है, ऑफ कॉपर इन अ गिवन टाइम विद इन अ गिवन एरिया. Means what? The concentration of copper per unit area, that is called as the productivity. Now यहाँ पर क्या क्या given values हैं, that is catchment area यहाँ पर दिया गया है 10 स्क्वायर किलोमीटर, जिसको हम मीटर स्क्वायर में कन्वर्ट करने से 10⁻⁷ मीटर स्क्वायर. कॉपर कंसेंट्रेशन इन स्ट्रीम सेडिमेंट टोटल क्या है 3000 पार्ट्स पर मिलियन. कॉपर बैकग्राउंड वैल्यू 200 ppm. सो डिफरेंस in concentration of copper, क्या होगा? The background value, the copper concentration in the stream sediment 3000 ppm minus the background value 200 ppm. This will give us a value of 2800 ppm. ठीक है. अब productivity. Now productivity of copper in the catchment area, what will be it? That is the rate of production, that is the concentration of copper, that is 2800 ppm, that is produced per unit area. कितना है? 10 to the power 7 मीटर स्क्वायर. अगर जैसे कि ऑप्शंस में हम लोग देख चुके हैं विच इज गिवन इन 10 to the power 6 मीटर स्क्वायर में फिर दिया हुआ है ऑप्शन, बट द एक्चुअल यूनिट ऑफ प्रोडक्टिविटी इज ppm पर मीटर स्क्वायर. अगर यहाँ पर हम देखेंगे कि ppm को मीटर स्क्वायर में कन्वर्ट करके हम डायरेक्टली मल्टीप्लाई क्यों ना करते इसको और इसको, दैट इज नॉट एक्चुअली पॉसिबल, राइट? वाई? बिकॉज ये जो ppm है ना, ये क्या है? इट इज द यूनिट ऑफ कंसेंट्रेशन and the meter square is a unit of area and both are depicting a different quantity, so they cannot be directly correlated. So ppm cannot be directly converted to meter square, it is not possible. So the unit of productivity is ppm per meter square. इसे हम लोग और सिंप्लीफाई करेंगे तो 2800 इंटू 10 to the power -6 ppm per meter square. ठीक है. According to me, this is the actual means जो according to the definition of productivity, ppm per meter square उसका यूनिट होगा, और अगर इसका यूनिट ये है तो this will be the answer. But in the given options यहाँ पर आप देख सकते हैं कि सिर्फ मीटर स्क्वायर में दिया हुआ है and 10 to the power 6 मीटर स्क्वायर में पूछा गया है. So this question is a little doubtful. And इसको गेट इसको लेके क्या करते हैं, तो we will see what the authority does with this question. So we will actually जो भी मेरा explanation था, I have explained it here. But for now, this is the correct explanation of this question. Okay. So we will move on to the next question. Question number 29. Question number 29 is also very easy. The combination listed below represents major mineral observed in 4 igneous rock. Okay. Olivine, anorthite, K feldspar, quartz, MgCa, pyroxene and Ca-Na plagioclase, amphibole and NaCa plagioclase. Arrange these mineral combinations based on decreasing temperature of magma crystallization. Same Bowens reaction series को हम लोग यूज करेंगे. हमें पता है कि Bowens reaction series का highest temperature mineral क्या है? Olivine और Ca plagioclase anorthite, और lowest temperature mineral क्या है? Quartz. Highest temperature mineral मतलब क्या है? Lowest stability mineral, जो कि इजीली वेदर्ड हो जाएंगे. मतलब क्या है? और वो जल्दी से जल्दी दे विल बी वेरी अनस्टेबल इन नेचर. क्वार्ट्ज, मस्कोवाइट, ये क्या होगा? द मिनरल्स दैट आर ऑकरिंग एट द लोएस्ट टेम्परेचर एंड द मोस्ट स्टेबल मिनरल क्वार्ट्ज. सो यहाँ पर क्या कहा गया है? ये जो मिनरल्स है डिक्रीजिंग टेम्परेचर के अकॉर्डिंग हमें अरेंज करना है. सो फर्स्ट क्या है? दैट इज olivine anorthite होगा because they are the highest temperature mineral. So one will be first. Next we have K feldspar, quartz, ये क्या होगा? लास्ट में आएगा. नेक्स्ट क्या है? MgCa, pyroxene और Ca-Na plagioclase. मतलब क्या है? pyroxene और plagioclase का Ca-Na component. मतलब क्या है? ये इसके बाद आएगा, थर्ड नंबर. नेक्स्ट वी हैव एम्फीबोल, NaCa plagioclase. नेक्स्ट पायरोक्सिन के बाद ही है एम्फीबोल और Na मतलब क्या है? एल्बाइटिक कंपोनेंट वहां पर आ रहा है, सोडियम रिच टुवर्ड्स लोअर टेम्परेचर दे आर ऑकरिंग. सो ऑप्शन नंबर 4 यहाँ पर आएगा. सो दिस विल बी द पर्टिकुलर टेम्परेचर जितना डिक्रीज करेगा दीज मिनरल्स विल ऑकर, राइट? सो 1, 3, 4 and 2. This is the option 1, 3, 4 and 2. So question number 29 के लिए 1, 3, 4 and 2 option number B will be correct. Okay, very simple. Bowens reaction series आएगा, ये वाला question easily कर लोगे. Shown below is a schematic plot of ND value, derivation of 143 ND by 144 ND in a sample relative to Chur versus time. The two solid lines represents the evolution curves for the depleted mantle reservoir and the continental crust. Which one of the four dashed line 1, 2, 3 and 4 represents the evolution of the chur? अब हमें क्या पता है, that is if we are talking of the chur, chur क्या होता है? chur पहले ये देख लेते हैं. देखो, in the case of the chur, it is particularly the chondritic uniform reservoir value, और ये जो वैल्यू होता है ये ओवरऑल एक कांस्टेंट वैल्यू होता है. ठीक है, कांस्टेंट वैल्यू जिसको रेफरेंस के हिसाब से भी लिया जाता है. सो इन दिस केस here particularly it is asked that within the two particular means ये जो 1, 2, 3 and 4 lines है which is representing a evolution of chondritic uniform reservoirs chur value, जहाँ पे हमें नायोडायमियम का particular मतलब concentration दिखाया गया है. यहाँ पर क्या है, the line 3 sorry the line this line it is representing the depleted mantle with respect to नायोडायमियम concentration. Depleted mantle मतलब क्या है, जो भी particular means we know that samarium neodymium का जो है, samarium क्या होता है, mantle में रहता है, और neodymium क्या होता है, partial melt के साथ crust में चला जाता है. So in that case the depleted mantle it will be enriched in neodymium, that is why it is having a higher ND value. जबकि the continental crust मतलब क्या है, within the depleted mantle the parent material that is samarium is concentrated, more samarium, more amount of neodymium that is formed. लेकिन जो amount of neodymium that is partially removed from the depleted mantle it is concentrated in that crust, और वो definite amount का होता है. So in this case the continental crust will have a negative value of neodymium compared to depleted mantle. लेकिन chondritic जो रेशियो होता है जो कि एक कांस्टेंट वैल्यू होता है, that will be not positive not negative, it will be 0. so ये क्या है पॉजिटिव, ये क्या है नेगेटिव, वो क्या होगा 0 होगा. so line 2 it is representing the particular value of chur. ये क्या है, chur का वैल्यू रिप्रेजेंट करता है. so option B it will be correct for this question number 30. ठीक है, answer will be B, question number 30.